work. Okay. So like I said, today we're going to be discussing the symmetric properties of roots, why they are important, what are their applications, why do we need them, among others. Okay. So let's see. Can you guys see the board?
Yes.
All right. Hansen here. I didn't hear her say good morning.
Good morning.
Okay, finally. Miss Hansen. Oh my God, I'm bored. When are we going to start school? I miss everybody. So it's Monday. According to my calendar, I don't know what part of the world you are or planet. Looks like February, right? So we'll be discussing the symmetric properties of roots. Focus today will be to use these properties to evaluate some expressions. Next lesson, because I want us to really practice that. So I won't be using the second, I won't be doing the second application of it. So the only area we'll focus on today is to be able to evaluate an expression using these symmetric properties of roots, okay? So take note of the objective. So before we begin, I would like you to have a look at these problems, the usual way you know it, okay? So when you watch this video, truly make sure you follow the same thing like everybody else. Solve these problems first before anything. So I will say let the first one, let alpha and beta be the roots of x squared minus x minus 6 equals to 0. Find alpha and beta. So find alpha plus beta. Let's work this out. Begin the first one, please. Let's take some time to do these two problems.
Do we need to tell you that we're finished?
Yes, but I need to see your workings. So
okay.
I need to see your workings.
Mm-hmm.
If you are done with question 1, could you say so?
I'm done.
I'm done.
Okay.
I'm done too.
All right. All right.
Yeah. Mr. Daniel, on my screen there's like gray boxes that's blocking the board.
Yeah, same. I'm not sure why.
How about this?
There's still part of the board that's cut off on the right side, bottom.
Can someone send me a picture of what you can see? Send it to the group chat on WeChat. You send a picture of what you see. Oh, okay. That's the chat stuff. How about now?
There's still a bit at the bottom.
Really?
Yeah, there's like a very small one.
That should be my pic. No, that's not me. Let's see.
It's bigger now.
It's bigger now.
Yeah. And
Oh,
that's
now
on the
it's all
top.
over the place.
Yeah.
What do you mean all over the place? Could you send me?
That's on the.
Now it's all over the place. That's the best way I can describe it.
So everything is fine now, basically.
No.
Can somebody send me a full picture of the screen? Else saying that's not the screen.
It's like this.
So you can't see me.
No, we can, but like I only took the board.
Can I see your screen if the screen is only the webinar? So let me see what your screen looks like. Okay. I don't know where that is coming from, but let's see. Oh, I see. How about now? How about now, guys?
It's still the same. It still has the boxes.
Okay, I'm just gonna close my Explorer. How about now?
There's the one on the top right. There's like a box on the top right. Oh, now it's like covering the whole thing, basically.
The top right should be me. I am actually confused. I don't know what's happening. And that is covering the question, right?
It's not, but if you write something there, we can't see it.
Yeah.
Okay. Oh gosh.
Maybe try to like avoid writing on like the side of the board, write in like the center.
This didn't happen last time, right?
Yeah, it didn't happen last time. Oh, now it's moved again. Box is moved again. Oh, it's back on the top right.
How about now?
It's at the top right now.
Nothing happened just now. Oh, no, it's there.
Like,
Oh, it shifted.
some application that's open?
Yeah, that's the thing. I close all the applications that are open. Let me see. How about now?
Nothing
Still
changed.
there.
Oh, it's bigger now. Oh, it's back. Oh, that one's bigger.
What do you mean bigger?
That means the area it covers is larger.
What?
Like it's the gray. Oh, the bottom bit just disappeared.
Can you send me a picture? Because I haven't done anything differently except to close Zoom and leave this window only.
It looks like this now.
You see, the thing is, what you see is actually that's me. That's the view I have of myself. And it's surprising that you have it, somewhere up there in your own case. Can somebody tell me what they see now?
The box is in the top right corner.
And it's
And
not.
bottom.
Oh, gosh.
And there's like a long one in like the very bottom.
All right, so we're just going to leave it at the top right so we don't waste time. Let's just get what you see at the top right. I'll send you my own screen. Yeah, that's what I expect you to see. Can Justin send me another picture of what he sees? Because this is what I expect everyone to see. Just simply send me another picture of the latest. That's the latest. So the box is quite big. All right, can you guys move the box away? Try to see if you can move this box away from your screen.
I don't think we can.
All right, don't worry about it. So let's see, hide floating meeting control. Let's see, escape. I'm trying to do some other stuff. Hide video panel. Can you still see me? Guys, can you still see me?
Yes.
Yes.
The box.
The boxes are still there.
I just
The big one's gone though.
Okay.
There's just one at the bottom.
Okay, can I see the one at the bottom you're talking about? Just one picture from anyone. Maybe Justin and Kaza can send me
It's
what
gone
is.
now.
Both of you send me what you see. Both of you.
There's one at the top though.
Oh, it's back.
It's back again. I'm not even doing anything.
I'll
Just
send
send me
you
what
a
I think
picture.
it's like showing your Zoom taskbar, and then whenever you click on it, then the box appears and it covers the screen.
Okay. All right. So let's just make use of what we see here. Okay. Are you done now with 2?
Almost.
Yeah, I'm done with 2.
2A. Okay. Could you send in what you did in the group chat? Anyone who has done 1 and 2, or just 1 or just 2, send me what you've done. Unacceptable work, sir. I don't know what you did. You just wrote 2, x squared minus 6x plus 7. Then the next thing, minus 7 plus 1 is your answer. Where does that come from? Where does that come from?
It comes from A and alpha and beta. I just took it from
How did you get it?
using the way you told us to.
How did I tell you to do it?
You told us to multiply the first term and the third term and find it.
Okay, and you got, I can see the 7x squared, which should mean, oh, that's question 2.
Yeah.
All right, so I can see 7x squared. And
then on the side, I put the things that make.
So if you had minus 7 plus 1, you get minus 6. But if you multiply 7 and 1, minus 7 and 1, you get minus 7, which is not a product. So that's the wrong.
I have made a mistake.
I can see that. And you need to show me question 1. If this is the short step that you have done in question 1, you haven't done anything. So Justin, I'm looking at your work. I can see how you solve to get your alpha and beta. I can see your substitution. Very good. Kelly, I can't see your alpha and beta. I can only see x1 and x2. I didn't ask for x1 and x2, Kelly. I asked for alpha and beta. Find alpha and beta. What I expect is alpha is something, beta is something. So that first step is unacceptable. Giselle, you just recalled the message. I can see that. Denise, looking at your work now. Very good how you did it. Very good, Melody. Rita, I can hardly see what you're writing. Is it that you write bigger or you take a better picture? Please do not send number 2 like this. Send a better picture. And I don't know, you use the same set of papers to send me your work. Can you use a normal paper? These kind of papers are like jotters or just journals or some not official stuff. So please. What is B? Who is this? Kinlon. I just saw in your notes, A, find alpha and beta, you work it out, you put alpha is something, beta is something. Then B, you wrote 3 plus minus 2. What's that? C, you wrote alpha, beta. So I know what you're doing in C, but I don't know what you're doing in B. Please adjust. You just wrote 3 plus minus 2. I don't know what that means. You should start with the question, alpha plus beta equals to, so we know what you're doing. Yanko, your work is seen. Alex, your work is seen. Joey, your work is seen. Giselle, your work is partly seen for the ones you sent. Okay, everything is seen now. Sonia, where does that come from? Find alpha and beta. Alpha is minus 2, beta is 3. From where? If this is a classwork and this is all you submit, it's nothing but 0. I've told you guys to stop using a lazy attitude in my work, in my lesson, in any activity that I give you. I need everything done. Don't just think about it. This is not mental math. You guys need to grow up. I've said it times without number. This is not mental math. When somebody give you question in grade 5, grade 6, and we only expect you to write 1, 2, 3, 4. I don't know when some of you want to grow. I've said it over and over. This is not the first year I'm teaching you. You know my style. What's this? Or could you look at question C? I don't know what is that. Is that 7 minus 2 times 3? B also 7 minus 2 plus 3, or what? What's that? I can see D also, you have 7 brackets minus 2 squared. What's that? Can you hear me?
Sorry, those are arrows.
That doesn't look like arrow. That looks like equals to 7. And what is arrow doing here? What is arrow doing here?
I'll redo it.
I expect alpha plus beta is equal to something. What is arrow doing here? I'm saying because the equation is monic, you don't have to go through this method of factorization. You're allowed to use one-step method to factorize. And this is an expression unseen. So your question A is unacceptable. I ask you to solve an equation, you factorize an expression. Can you see your mistake? If that is how you have done B, I hope you do not try that in the tests when the school begins. Mr. Ironman, again, your question 1A is unacceptable. All I can see is x squared minus x minus 6 equals to 0. You multiply, then you wrote minus 3 plus 1, minus 3, 9 times 2, minus 3 plus 2. Then you pick alpha is minus 3, beta is 2. No. You don't know what I mean by find alpha and beta? It means solve the equation. Do I have to spell it out? It means solve the equation. Alpha and beta are the roots. Find alpha and beta simply means solve the equation to find the roots, not find the factors. Come on. Candy, I don't know if you can see what you have written on this paper. If this is how my board on Zoom looks like, tell me how easy it will be for you to see. So I'm going to assume I didn't receive your work. Thank you. Elsin, are you solving an equation or factorizing an expression? And where does alpha equals to beta equals minus 3 come from? You solve the equation before you pick your alpha and beta. I don't see you solving an equation, Elsin. So you work unacceptable. Oh, your work is received now. Looks better. Crystal. Alpha equals, is there a way you pick beta before alpha, Crystal? Can you go alphabetical order next time? And also, can you get your x equals 3, x equals minus 2 before you pick them? So one step is missing. Thank you. Work received and acceptable, Charlene. Your work is still not acceptable, Mr. You factorize x minus 3, x plus 2. I didn't give you an expression, I gave you an equation. I can't see you solving the equation. You only just wrote the answer. So you know the answer, so you just want to write the answer. This is what I have. X minus 3, x plus 2, x is 3 minus 2. What's this? I'm sure this is not how I taught you how to solve equation. So that's not acceptable. If that was a class work, it's not acceptable. Answering your adjustment is noticed and work acceptable. Candy, this is better now. Thank you. And your work, question 1A, is unacceptable. I can only see you factorizing, and from your factorization, you pick alpha and beta. And there shouldn't be any or. Alpha is this, beta is that. There's no or in this case. Thank you. Else, your adjustment is noticed, except the first line of your solution. I don't get it. You only have an expression. You're supposed to start with equation every step of the way. Please adjust. Thank you. Kelly, your work has been received and is accepted. Kelly, you need to be mindful of how you take your picture. I noticed this also during your online submission. If you notice, the top part of your picture is not always clear. I need to just assume that I understand what you are communicating because it's blurred at the top part. So please, if you look at the picture Giselle sent compared to the picture you sent, there is a clear difference, Kelly. Giselle, question 2 received. Answering, please change the orientation of your picture. What you sent in is not acceptable. Thank you. I'm taking a note of those that are responding and those that are not responding. I'm taking notes. And trust me, this is part of our efforts. Elson, the latest work is accepted. Anson, I got your latest work. 2B accepted. I'm waiting for 2C. Is it 2B or 2A? Oh, is this 2B or 2A? Can you put the number properly? That question is not B, that is question 2. Please change your numbering. Mr. Ironman, please look at the board. Squared minus x minus 6 equals to 0 is the problem. I expect to see x minus 3, x plus 2. Next line. This is 0, or this is 0. If If you're too lazy in my class, you cannot get the required points in my class. And once you do that, then you can pick one as your alpha and one as your beta.
Oh, okay.
I don't think this is too much to ask. This is all I ask you to do. Because it's monic, you don't have to show me the detailed factorization. Those that have called to adjust and send your number doesn't add up. I don't know where you got B from. Is this 1B or 2B? The equation you have solved. I haven't heard from some people. Yeah, that's better now. You need to learn to show detailed work and not assume, oh, he understands. Come on, these are external exams. Nobody knows you. So stop having this mentality of my teacher understands what I'm trying to communicate. No, we don't. If you do not tell us, we don't know what you are communicating. Hansen, I never gave you question 3. There are only 2 questions, so I don't know where you got all this from. Let's look at the board and adjust accordingly. Thank you. I don't know where question 3 came from. So how many question 2C do you have? So can you guys tell me what you see now? Hello?
We only see the board. We don't see any black spots anymore. Black spots anymore. Yeah.
Just the board now. Good. Can somebody send me a picture? All the gray pictures, whatever, are gone. Thank you so much for that. So I think now I can put my video up. How about now?
It's still only the board.
Oh, finally. I had to
finally.
I had to uncheck something. Oh, good. So guys, this is it. I'm going to send something to our group. So as I'm making this, do you see the blacks, gray, whatever now?
Yeah.
We saw the gray box, and there's a bit of gray boxes on the top and the bottom on the right side. Yeah. Oh, now it's gone again. Yeah, it's gone.
So that's it. I just sent to you what happened. Now I've taken notes. I learned something also today. Can you see what I sent to the group? Miss Shirley, checking your work now. Good. Thanks, Kelly, for the picture. Joey, I'm checking now. Oopsie. Gotta go. Be back. I'll be right back. I need the battery. Rita, I don't know if you can see what you have sent because I can't. Thank you. Can you look at what other pictures look like? If you are using a paper with not so white background, I expect a deeper color of ink, like maybe blue, some deep black, not like a gray pencil on a gray-like background. Come on, I don't know. Look at what Denise just sent, for example. She's using maybe a pencil or a pen, I don't know, but the background is so white so I can see clearly. So some of you do this also when you're sending in your homework, and I have to either, be more careful trying to look through exactly. Please, you need to make things easier for me as well, not just give me unnecessary punishment because you're submitting work online. So what I would do is just reject the work until you're ready to give me the right output. I don't know if anybody can see what you're sending in. Come on, look at it yourself. I can't even see the first part, even as I zoom in. I can't even see anything in the first part. I assume that is let alpha and beta. That's just an assumption. Every other thing I don't know. If your work is not clear, I won't, stress myself to try to see what you are doing, please. Thank you. The quadratic equation, the quadratic formula is minus b plus or minus. Can that young man adjust it? So your alpha and beta are wrong. Carter, I'm talking about you. Kinla,
Yes.
I'm checking your work. The only thing is, if I zoom this now, I don't think I can still get a better picture. Anyway, we can make use of that. Yanko, I would be interested in how 6 plus or minus root 8 divided by 2 becomes 3 plus root 2, 3 minus root 2. I don't know how you jump from that first step to the second step. So if there is no reason, if you don't know how others got it, you can say something, but you can't jump from one step to the other just like that for no reason.
Okay, I'm sorry. I'll change it. Wait.
This must be Denise. You have your alpha equals that, beta is that. Did you use calculator to do the evaluation? Denise, I'm talking about 2B and C. Does that calculator work? Is anyone called Denise in this class? So what happens to your mic?
Hi.
You use calculator, I guess. Hello.
Yes, I used it for 2B.
2C.
Yeah, 2B and 2C.
All right. I would have loved to see how you work it out with that calculator. But if the best you could do is using calculator, then that's fine. Okay, so I'm going to move on now. I'm going to Joey, your work received. Adjustment of your work received, Carter. Now, I need you guys to tell me how easy this was for you. Sonia, work just received. For those that haven't submitted their work, well done. Congratulations in advance. OU, your work received. I need you guys to tell me what are the difficulty you encounter while trying to do this. Am I the only one who couldn't see Rita's work? Can you guys help me out here? Maybe I'm the only one, I don't know. Because it's still very tiny, Rita.
Mr. Daniel, I think you need to download the full image, like
Oh, okay.
on the bottom. Yeah, if you click it, it'll become like clearer.
Oh, okay, okay. Okay. In that case, Rita, I wouldn't advise you take a full page picture when submitting your work because I have to zoom in all the time to see what this is. Yes, I'm waiting for replies. Talk to me. If your mic is working, of course, you use your mic. How easy was this for you?
Not very easy. It takes a long time
Yeah, it's
and a lot of steps.
hard. It's hard with like
Yeah.
roots.
It's hard with the roots, okay? I'm taking note of that.
It's easy but very tedious, and I make mistakes.
Okay.
I think you mean like time consuming, but okay.
I'm not talking about the timing. I'm talking about how easy was it. So it's not about the timing. If something is easier to do and you spend 2 hours, that's fine. But if you spend 30 minutes and you have to go through hell to do it, then that's not so cool.
Oh, it's pretty easy then.
You get my point? So yes, let's get other comments. I can only hear from like few people. I don't know why the rest are so quiet. Some of you are just like laid back in the class, and I'm not happy with that. And I've told you times to that number. And if you're not responding, I'm going to have to call your names. So I look forward to hearing from others. How easy was this for you? Thank you.
I think it's not very hard for me. But when I'm doing question 2, I made a mistake at first, but I corrected.
Why do you think question 2, you made a mistake in 2?
Because the root is not it's a complex number.
It's not a complex number, it's just complicated calculation.
Yeah, the calculation is more complex.
How easy will it be if I ask you to do something like this and without calculator? I didn't ask you to work it out. I'm asking you to comment on this. Still on question 2, if this was 2D and you're asked to do this, how easy will it be for you? I need comments.
Without a calculator, I find it very hard.
Speaking, can you speak louder and clearer?
It would be fine for me.
Yeah, somebody was speaking earlier. Can you say that again?
It would be pretty hard without a calculator.
It would be what?
It would be pretty hard without a calculator.
Really hard without calculator? Yes, more.
Yeah, I agree with Kinlaw.
Yeah, I agree as well.
Pretty hard without calculator.
And why do you think it will be very hard? Will it be hard for question 1?
No.
No.
If this was 1F, will it be hard?
No.
No.
Not really.
What if no or not really? Just stick to 1.
No.
No.
It would be much easier if it was 1F.
Why do you say so?
Because the roots for 2 there is 2 terms. 2 terms.
For
That's
2
how you say it.
terms, what do you mean 2 terms?
It's 3 plus root 2 and 3 minus root 2, but for 1 it's only just the number.
I think you can put your explanation in a better way. In one sentence, why do you think it would be easier for question 1?
Question 1's roots are whole numbers.
Okay.
And question 2's roots are surds. So it's harder.
Surds. So question 1 does not contain surds, basically. Yes? So question 1 does not contain surd, and that is why it will be easier to do this problem in question 1 than question 2. What if I told you, now, the process, I haven't heard from Anika. I am going to call out names of those that have not said anything, and I've taken note of your names. So if I'm to grade you effort-wise, I don't think you have gotten any effort for today. I didn't hear from Alex in the discussion. I didn't hear from Candy. I didn't hear from Sisonia. I didn't hear from Krista. I didn't hear from Denise. I didn't hear from, let me see again. Let me see. Krista, I didn't hear from you in the discussion. I didn't hear from Denise, like I said. Oyu, I didn't hear from you. Joey, did I hear from you? I'm not sure.
Yes, you heard from Joey.
I heard from Joey, okay.
Yeah, at the start.
Melody, I didn't hear from you. Rita, I did not. Shirley, I did not. I think that's pretty much those that I didn't hear from. So if I call your name, I will advise you in the next discussion, you speak up so I can at least have an evidence that you deserve whatever effort, good effort that I'm going to be given. All right. Now, so the process of solving this question so far, so if the question was alpha and beta are the roots, maybe question 3, of course there will be no question 3. If alpha and beta are the roots of some equation ax squared plus bx plus c equals to 0, if alpha and beta are the roots, of course a, b, c are numbers, I'm just picking like random stuff, or maybe I use a normal number. So alpha and beta are the root of maybe 3x squared minus x minus 2 equals to 0. And the question is to find this. Can somebody walk me through the process, especially those that have not spoken today? If I've called your name, you have a chance now. I didn't ask you to do it. I asked you to walk me through the process. So all you have to do is explain what to do.
So first you either factorize the equation or you use the quadratic formula to find alpha and beta.
That's Candy, yes?
Yes.
Okay, next.
And then you substitute the alpha and beta into the second equation.
The second is an expression, actually. So you substitute into the expression. All right, very good. Very good. Now, taking notes for Candy. So basically, for now, we have to go through 2 steps so far. Okay, So far, the first step is to solve the equation. The second step is to get alpha and beta. And the third step is to substitute into the expression. Am I right, everyone?
Yes.
Now,
Yeah.
what I told you,
Yeah.
you don't have to solve the equation. Can somebody tell me why you solve the equation? Why do we need to solve the equation for now?
To find
the roots.
To find the roots, very good. Because without solving the equation, we cannot get the roots. If you do not get the roots, you can't evaluate by substituting, right? What if you don't need to get the roots, let alone substituting? From this equation, from this alone, you can get what this is, you can get what this is, you can work this out, you can work this out. That is the purpose of today's class. Without identifying the roots individually, how can we get what happens to them? Look at question 1. Without getting alpha and beta, I want to find out what happens when I square alpha and when I square beta and add together, even though I do not know what alpha and beta are. Wouldn't that be a good thing to know instead of going through all these roots, raised to power 3, square raised to power 2? You understand what I mean? Roots raised to power 2 and things like that. Am I making sense, anyone?
Yes.
You get my point? Remember when I asked you what were the problems you encountered, you told me what? Oh, question 2 is complicated because of the roots, right? Question 1 is easier because it doesn't contain the roots. If question 2 was a fraction and I give you this question, it will be easier, but not as easy as question 1. Do you agree with me? Because you have to, this will be a fraction divided by fraction. Does that make sense, everyone? Then,
yeah.
If this was question 3, then it becomes more complicated because now we are dealing with roots. What if we don't even want to know what the roots are? We don't want to know, but we want to know what will happen if you do the cube or you add the cube to another cube and things like that. That is the purpose of the symmetric properties of roots. So I ask you to go through these stressful steps so you can appreciate what we are about to do. Okay, so let's go to the next slide. I've asked you to do some extension in the last homework. Now is the time to bring that on board. In the last homework, remember the extension part. I think that was question 8. Okay. So I'm going to say, what if we do not have to first solve for alpha and beta? Okay. To do this, you must learn the following symmetric properties. Roots. Just take note of that. So we begin with from if alpha and beta are the roots of quadratic equation ax squared plus bx plus c equals 0. Now this is the general form of quadratic equation. Yes. You know that x is equal to what? Class? What is x? And can anybody hear me? Hello? X is equal to what?
Alpha or beta?
What do you mean? How do I get x? I mean, what is the value of what is x? That's my point.
Minus b plus c. Use the quadratic formula.
Quadratic formula, minus b, thank you. That was Anson, right? Then Kelly. So x is equal to this. Class, understood?
Yes.
Yep.
This we already know, that for any equation, this is your roots. This is what gives you your roots. Yes? Now,
Yes.
thank you. So to make it easier, we're going to let our discriminants be replaced with this. So I can write x as minus b, just to make our calculation easier. Since I do not know what, these are not numbers, we're only writing in general form. Okay, we're only writing in general form. So this seems like our last answer. So in that case, Anika, what would be my alpha? Anika, what is alpha, please? Is Anika there?
I think Anika is not here.
Really? Oh, yeah, somebody's messaged me that she's not available today. Thank you. I'm going to be asking Sonia, what is alpha, please?
Alpha is the discriminant of
Can you say that again? I'm waiting.
I think that alpha is equal to x.
Equals to what?
X.
X. Can you look at this stuff that we did here? We didn't just say alpha is equal to x, did we?
It's minus the minus b plus square root d divided by 2a.
Shirley, what is beta? Please, when I call your name, I need response in seconds. Because we have other things to do and we have stuff to achieve.
Minus b minus square root d divided by 2a.
Okay. So that's our alpha and that's our beta. We want to see what happens to alpha plus beta and alpha beta. So with this, let's see, we're going to deduce something for alpha plus beta, sum of the roots. So alpha plus beta is when you have these two together, minus b plus root d divided by 2a, and minus b minus root d divided by 2a. So 2a is a common LCM, minus b plus root d, the minus b. Please don't use plus minus. I already multiplied this plus by both of them. So what does this become? Minus b is minus 2b. Can we see that? I need response, please. This
yes.
Yes.
So what do we have now? Alpha plus beta is what?
Minus b over a.
So this is something that we are looking forward to obtaining. So that's our alpha plus beta. We will see the implication of this very soon. Let's see alpha beta in a similar way. Alpha beta, which means we multiply, minus b, maybe I don't need the brackets, plus root d divided by 2a, multiplying minus b minus root d by 2a. Now this is multiply numerator. Multiply the denominator. What does this numerator look like?
A square number.
Nope. Think again. Nice try. Think again.
Difference of
Difference
two
of squares.
squares.
Difference of two squares. Justin, can you tell me what this would be in difference of two square form?
What do you? Is it b squared
Close.
minus d negative b squared
Negative b squared minus
d? Oh, sorry, square root d.
Thank you. Square root d squared. Does everybody understand that? Talking to 20 people or 19 people. Does everybody understand that?
Yes.
Thank you. So this will be positive b squared minus d. Yes. So divided by 4a squared. So that is positive b squared minus, so our d is here. Everybody knows why I use the brackets?
Yes,
Yeah.
because it's
Yeah, because there's a minus in there.
Yes, good. So that is 4ac divided by 4a squared. What does this reduce to?
C over a.
Good. So alpha beta is simply c over a. This is one of the tools you need to have and always remember. Let's come back to, so again, everybody take notes. Alpha plus beta is minus B over A. Alpha beta is C over A. Let's come back here. What is A? For this first question, what is A?
1.
And what is B?
-1.
What is C?
-6.
-6.
So alpha plus beta is minus B over A. What is minus B? 1. So minus B over A will be -1, right? Over 1, which is -1. If you check your answer, you should have got -1 here. Okay? Alpha beta is C over A. C over A in this case will be what? -6 over 1, which is -6. Can you see that? Talk to me, guys. Please, when I ask question, I need to respond.
Yes.
Your silence does not mean
Yes.
understand. It is your response that makes me know that you understand, all right? So I don't want absolute silence. Thank you. Are this what you got from your number 1? Are these answers?
Miss.
Yes.
Isn't
Wait,
B
isn't
just
it-
1?
Yeah.
For B,
Yeah,
I
it's
got
1.
Yeah.
Yeah, it's 1, not -1, yes. Minus is plus. So you got +1 and -6. This is +1, this is -6, correct?
Correct. Yeah.
Yes.
Basically, without solving for alpha and beta, you can actually get alpha plus beta and alpha beta. That's the point we are trying to make. And the same thing happens to your quiz that I gave you last week. What is this? What does alpha plus beta mean? Anybody?
The coefficient of B?
No, think again. The main coefficient of B. What does alpha plus beta mean? What does it mean?
The sum of the roots.
Sum of the root, that's what I want to get. The sum of the roots. So if alpha and beta are the roots, alpha plus beta is the sum of the roots. So which means we do not need to solve for the roots to know what their sum is. Does everybody get that? We do not need to solve for the roots to know what their sum will be. That's the point. And if you remember from your quiz last week, I asked for alpha plus beta. I asked for, sum of the roots. Yes, alpha plus beta and alpha beta. And the product, sum and the product. Does everybody remember that from last week quiz?
Yeah.
So this is what you need to do henceforth. Even though last week I expect you to use the fact that we already know the equation is this. We'll be taking the correction because everyone has now turned in their work. So we'll be taking the correction much later. Then this will even make us understand the idea better. Okay. So again, to find sum of roots, just get your ABC. Minus B over A is the sum. C over A is the product of the roots. We don't have to know what the roots are, but with this, you can find the sum and the product. Now, you might be wondering, how does that help us to get this and questions like this, and maybe difficult questions like this? Okay, so there are some expressions that are called symmetry. Okay, what are symmetric expressions? An expression is symmetric if it's an expression that involves alpha and beta is symmetric if whenever alpha and beta are, alpha and beta does not need to be the same, all right? They can be different. If when you interchange alpha and beta, you still get the same thing, or when you when you interchange them, it looks like you have just multiplied the original expression by -1. I will explain what I mean. Look at this. Alpha squared, beta squared. If I change the position of alpha and beta, do I get the same thing?
Yes.
Yes, you get the same thing.
Look at alpha minus beta. If I change the position of alpha and beta, what does that become? It becomes beta minus alpha, which is what? The negation of this, right? Can you see?
Yes.
Yes.
So any expression where you can change the position of alpha and beta, if I have 3 alpha plus 3 beta, and I change the position of alpha and beta, so it is now 3 beta plus 3 alpha, I still get the same thing, okay? Or if I have alpha squared minus beta squared, and I interchange the position, I'll be getting beta squared minus alpha squared, which is like multiplying this by -1, isn't it? Any expression that satisfies these two is said to be symmetric. Okay? These are the expression we want to be dealing with in this situation. So when you have an expression that is symmetric, we can make use of what you have learned in this place and what we're about to deduce. All right. So let's write the symmetric stuff. For expressions that are symmetric, let's write this. You can copy all this later if you leave space for the previous slide, okay? Symmetric expressions or symmetric relations, as the case may be, okay? Can you see this? Everybody still see the board?
Yeah, I still see a board.
Okay. The example that I gave here is this. Maybe we can include that. And here we can look at maybe alpha cubed minus beta cubed. So 7 alpha minus 7 beta. Yeah, I could use the other one too. Please confirm if you get what I've said here so far. Does everybody get what I've said here so far?
What does
Yes.
2 mean?
Yes, what?
What does the number 2 mean?
If you multiply by -1, okay, now for number 2, so this 7 alpha minus 7 beta, okay, if I change the position of alpha, this is the original one, right? If I change the position of alpha and beta, I get 7 beta minus 7 alpha, yes?
Yes.
And this is actually negative of 7 alpha minus 7 beta.
Okay.
So if it's multiplied by -1 when you interchange the position. So if I multiply this by -1, I get this. Do you agree?
Oh, okay. Yes.
So if you multiply the original by -1, you get the interchanged one. Okay. If you change the position, it looks like you have multiplied by -1. That's the point. So all you have to do is write down the original one. Okay. Interchange the position. Okay. Then see if when you factorize -1 out of this. If you factorize -1 out of this, what do you get, Justin?
Factor -1.
Yeah, from here.
And minus 7 alpha 7 beta plus 7 beta.
Plus 7 beta. And when you write this properly with the positive coming first, what do you get?
Positive. Sorry, what do you mean? 7.
Yeah.
Oh, okay.
So you notice that this is the original one. This is what you get when you interchange them. Okay? So that's what we mean by if it is multiplied by -1 when we interchange. So if you interchange, it looks like you have just multiplied the original by -1. That qualifies for the second one. Does this make sense to everyone?
Yes, thank you.
I do not want to get to step 100 before somebody tells me I don't understand. And Alex, hear me, because I don't want you to come back 100 years later and tell me I don't understand from the beginning. Alex?
Yes.
Can Alex hear me?
Yes, I can hear you.
Is there a problem so far?
No.
Okay. All right, so we assume everybody gets that. So this is the meaning of symmetry. It is the meaning of symmetry in terms of the relation. But there are some relations that we need in terms of an expression. This is what all this kind of expression that we evaluate, they have to be symmetric. Now look at this. Look at the exercise you did. Is this symmetric? It's 1D symmetric.
Yes.
Yeah.
I'm taking note of where my response comes from.
Yes.
Yes.
Okay. Yeah, it's 1B symmetric.
Yes.
I think so, yeah.
Yes, it's also symmetric.
It's also about 1C.
Yes.
Yes.
How about 1E?
1D?
Yes.
Yeah.
Yeah.
That's symmetric also. All right, let's go to 2C.
No.
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 No, why? Have you checked the two criteria and it doesn't satisfy?
But yes, it does. It is.
So it says 3 alpha squared beta minus or plus minus 3 alpha beta squared. Interchange the position. First factorize the minus, you get 3 what? 3 what? Alpha beta squared. This one will come first. then this next. Yes?
Yes.
Yes.
So this is when I factorize. So now I'm going to interchange the position. If I interchange the position of alpha and beta from here, I want to see if they are this, if I get the same thing in this bracket. If I interchange the position of alpha and beta here, I get 3 beta squared alpha minus 3 beta alpha squared, correct?
Yes.
Yes.
So if I rearrange this in alphabetical order, what is this?
But alpha
beta
squared.
Minus 3 alpha square.
Isn't that what you have in this bracket?
Yes.
So, symmetric or not?
It's symmetric.
So we can make use of it as being symmetric. So that's now you are able to, we'll be able to work out anything that forms that we can see symmetry in. Now there are some relations that we need. These expressions are of symmetric in nature, but there are some relations that we really need. And the only relation we'll be looking at is what happens to the square, the cube, and the difference. Well, I won't go beyond square, cube, and difference. Okay, when you get to higher levels, you might be introduced to other stuff. So some important relations. Okay, so first we will be looking at, I'll write the 3 here. How can we write some important relations, symmetric relations in terms of alpha plus beta, alpha beta. So the first one, we want to see alpha square plus beta square. Okay. Okay, maybe I'll put it this way. I write the 3 first. Alpha squared plus beta squared. The second we want to look at is alpha cube plus beta cube. And the last one is alpha minus beta. So in every calculation you'll be doing, you'll be making use of this. Okay. And what do I mean by this? Let's take the first one. Let's consider, because this is square, I'm going to consider alpha plus beta all squared. Can someone tell me what this is? How long are we going to wait before somebody speaks up?
Alpha square plus beta square plus 2 alpha beta.
Does everybody get this?
Yes.
Yes.
Yeah.
Now, this is just normal expansion. We want to get alpha square plus, we want to get a relation. When I say a relation, like a formula, okay? Like A equals L times B. This is a relation, okay? Something that connects. You want to express A in terms of this. Do you understand? So we want to express alpha square plus beta square in terms of these two. That's the whole idea. Am I making sense, please? Please talk to me.
Yes.
Yes.
Okay. Now, So if I need only this, I need to bring this to the other side, right? If I take this to the other side, then I'm going to be getting alpha squared plus beta squared equals what? See?
Alpha plus beta all squared minus 2 alpha beta.
That is one of the relations. So the idea here, let me just tell you ahead. The idea is if someone asks you for this problem, okay? Without solving the equation, you can get the sum of the roots. You can get this and this. Am I right?
Yeah.
And now that you can get these two, with this relation, you can find the alpha squared plus beta squared. That's the idea. Let's see. From this one, this is the complicated one. Okay, let's see. Then you can compare with what you have. From this, x squared minus 6x plus 7. You get to alpha plus beta minus b over a, which is minus 6 over 1, which is 6. Alpha beta c over a, which is 7 over 1, which is 7. This question is asking for alpha squared plus beta squared. Then you say alpha squared plus beta squared, according to this relation, it's alpha plus beta all squared minus 2 alpha beta. Can you see? Then you substitute this and this. 6 squared, 2 times 7, 36 minus 14, 22.
Oh, okay.
Can you see that?
Yes.
Yes.
How we save ourselves the stress of expanding and all the other nonsense. So the whole idea is when you have a symmetric expression, let's look at the other one. Look at this too. Look at this. So all we have to do every time is whatever you are given, express it in the form of alpha plus beta and alpha beta, because they are easily found. They are easily found from here directly. Does that make sense?
Yeah.
Yes.
So we don't have to go through these 3 steps. That's the whole point. Okay, that's the whole point. So, but we will limit our discussion to cube and difference. Okay, because we can have other powers like power 4, power 5, power 6, but we don't have to go through that stress, at least for now. Okay, so the whole idea is this. Let's quickly move on because we're running out of time. Let's see. So this is for square. So you need to remember this, which is why you need to state it all the time, and which is why you need to be part of this discussion, because there's no formula booklets or whatever when I give you a test of this form, in this case. So also, maybe I change the colors so you don't mix them up. So for the cube, who can guess where that will come from? What do we consider? To get something for this, in terms of to get a relation for alpha cube plus beta cube, what do you consider? Can somebody guess?
Alpha plus beta all squared.
Really? Consider the same thing? For you, that's what you have just said.
All cube.
Why do you say squared first? So we
sorry, I just woke up 2 hours ago.
all right. So we consider the cube this time. Okay, alpha plus beta all cube. Okay, and I'm aware you're in Form 4, so you don't know the tricks of using Pascal triangle. So we're going to do this the normal way. So I'm going to say this is alpha plus beta multiplying alpha plus beta squared. You agree? So this is alpha plus beta, and this is alpha squared 2 alpha beta squared. Am I right? I think it's easier if I have the square on the first one. The terms are automatically collected. Talk to me, do you understand what I'm doing?
Yes.
Yes.
So this will be, so I multiply, can you see that? So that's gonna be what? Everybody.
Alpha cubed plus alpha
squared beta.
Okay, then this middle.
2 alpha squared beta plus 2 alpha beta squared.
Then the last will go again.
Plus alpha beta squared plus plus b cubed. Beta.
So now this is the reason I put this first, because automatically they are collected. Can you see that? So this means our alpha plus beta cube equals to, so OU, can you see I'm not replacing arrow with equals to? Arrow is to link two separate lines. That is what this means. Arrow means, this is like saying this means is not to be used for equals to. So if you don't know the usage, you can avoid using it. So this is 3 alpha squared beta. Yes. This is 3 alpha beta squared, and this is beta cube. What do you propose we do next? Anybody? Anyone?
Take the things, take the 3 alpha squared beta and 3 alpha beta squared to the other side.
Yeah, and keep only this, because that's what we need. This is what we need. Yeah, so this implies that alpha cube plus beta cube equals alpha plus beta cube minus 3 alpha squared beta minus 3 alpha beta squared. Yes? So, what is the goal here? Anyone? What is the goal?
Isn't this the goal already?
No.
To express it further in terms of alpha plus beta and alpha times beta.
Does everybody get that?
No.
The goal is here to express it in terms of alpha plus beta and alpha beta. Is this in terms of the goal?
Yes.
Is this in terms of the goal?
Yeah.
Yes.
Really?
Not really. Not really.
Oh wait, no, there's a square there. There's a square there.
Is this in terms of the goal?
No.
So you are not there yet. That's why we are not there yet, Justin. So this gives alpha cube plus beta cube. Because the first one is okay, so we don't have a problem. But these two are not. What do you suggest we do?
You factorize it.
You can factorize it. What is the common factor that you can get from here?
Three alpha
3
beta.
alpha beta.
Good. Not 3 alpha beta, please. Think again.
Negative 3 alpha
Negative.
beta.
Thank you. Negative 3 alpha beta. So that's how we now get to the last point. Alpha cube plus beta cube is actually the sum that we have found. You raise it to power 3. You subtract 3 times the products, and you multiply that by what? What do you have in the bracket?
Alpha plus beta.
Does this look like the goal?
Yes.
Yes. Now this is the goal. As long as we have it in terms of alpha plus beta and alpha beta, we are good. This is the goal. So this is another relation. So this is the relation for cube. This is the relation for square. So we have to be able to remember this. We have to be able to remember this. This is easier to remember. The sum and the product. These are easier to remember. Okay? You have to be able to remember. The last one is for subtraction. For the subtraction, can anybody guess what we will consider? Because for square, we consider all squared. For cube, we consider all cube. For subtraction, what do we consider? Anyone? Let's make just try. Anyone? Anyway, we consider this. Somebody tell me why this might be something to consider. Can you see that?
Yes, we can see that.
Okay. How can this help me to get this? Anybody? Anyone?
Could it be factorized?
This is what I want. I want to get an expression for alpha minus beta, right? How would this help me achieve that?
Move the -2 alpha beta.
Are you sure?
No, I'm not.
If you move the -2 alpha beta, you are getting for this again.
Oh, okay.
But that's not what we need.
Get rid of the square root. No, wait, no, get rid of the square.
Get rid of the square. Who was that?
Melody.
Melody. Okay. We get rid of the square. Can you see? If we get rid of the square, this is what we want. Okay? So before we get rid of the square, you need to make sure. So basically, we're going to be having this. Can you see that? Class, please talk to me. If you understand.
Yes, we can see that. Yeah.
Yes.
I need response. I need to know if you are getting what I'm trying to bring out here. So don't be quiet. Your silence does not tell me that you understand. Thank you. So if we can get if we can simplify this further, then we just find the square root. But whatever you have under the square root must be in terms of alpha plus beta and alpha beta. Whatever you have under the square. Okay, because that's the goal. So we need to now simplify this further. This will be the last slide because we have to leave. Alpha squared plus beta squared minus 2 alpha beta. Any questions?
No.
Okay. Let's see if we are there yet. So because if we once we have achieved our aim, we find the square root. Does this look like the goal?
No, but yes, I don't know.
That
Yanko? Does
I'm kind of confused.
What, confused about what the goal is or what?
Yeah, what the goal is.
So the question is, what is the goal? Can anybody remind him what the goal is?
Show it in terms of alpha plus beta and alpha beta.
Thank you. So this is your
Oh, okay, okay.
So does this look like the goal?
Yes.
Yanko, does this look like the goal?
Yes.
Why?
Because it's alpha beta.
That's it. Now, what about this? Does this look like the goal?
Nope.
No. Yanko, does this look like the goal?
No, because it's squared.
It's squared. So now this doesn't look like the goal, this looks like the goal. So we don't have issue with this guy. So we're going to ignore it for now. But this does not look like the goal. Can I ask Sonia to suggest something to do to make this look like the goal? Sonia, please.
Can you pardon the question?
What?
Can you pardon the question?
You mean repeat the question?
Yeah.
This looks like the goal, according to the class. This does not look like the goal. Do you know why this looks like the goal?
Yes, because it's alpha beta.
Good. But this does not because of the square. Our goal is to have only alpha plus beta and alpha beta. You may decide to square everything. You may decide to multiply everything by 2. You may decide to do negative. You may decide to divide. Nobody cares. As long as you can see alpha plus beta and alpha beta all true. That's the goal. Now, this looks like the goal. This does not. So my question is, can you suggest something that can help us simplify this further so we can achieve the goal?
You square root it.
Square root of this?
Yes.
And now will that help us? Like if I square root everything or just this one?
Only that one.
Only this one?
Yes.
So does it mean if I want to evaluate, if you give me 9 plus 8, I can just square root these parts and write 3 plus 8 and get 11 instead of 17?
No.
You can't just square root. Besides, you can't even square root, you can't find the square root of this. You can't. The square root is not alpha plus beta. Please take note. Because when we expanded this, we didn't get just this. Do you understand? So
Yeah.
if you can find the square root of this is not this. Denise, your turn.
Yeah.
What can we do to this to simplify further?
Bracket alpha plus beta bracket squared minus 2 alpha beta.
Exactly, using this relation. We can use this relation. So Sonia, did you hear that?
Yes.
Can you mute your mic? If you are not responding to question, mute your mic because some background noise are really annoying sometimes. We can't tell people behind you not to speak. It is your own responsibility to mute your mic so it doesn't disturb our class. And when you're ready to talk, when questions are asked, you unmute your mic. Thank you. So this is what we bring in. Okay, so we're going to say alpha minus beta all squared equals, maybe I write it here so it's easy for you to see. So this is equals to alpha plus beta squared minus 2 alpha beta, then minus 2 alpha beta. Remember, from what you know, this is this from the previous relation. Can we see that, everybody? So I'm going to write here and say from, maybe I write them as relation 1. Maybe I write this as 1. I'm going to write this as 2. We can write this as 3. We can write this as 4. Okay, so we're going to be saying from relation 3. No, 2. Is that, this will be 3, actually, yes, this is 3. Am I right, everybody? Is this 3? This will be 3. So this is 2 and 1, okay? So this is 3, and this is 4. Okay, so this is from relation 3. Do you understand, please? Everybody confirm?
Yes.
Yes.
Yep.
So what does this give us now? Which implies that now everybody, alpha minus beta all squared equals what? Come on.
Alpha plus beta.
I hate silence.
Alpha square minus.
Where does that come from again?
Oh,
Alpha plus beta also.
Now I want Justin to be quiet because it seems to be the only one, and some other people. Yes, Justin said alpha plus beta. I need someone else to pick that up. And everybody.
Bracket square minus 4 alpha beta.
Who doesn't know how we got this? Does everybody know how we got this?
yeah, I know how we got this.
Yes.
Okay. So
Yes.
the relation for subtraction now will be what? Someone else apart from those that have spoken. I don't want to hear from Giselle. I don't want to hear from Elsane, Justin, Kelly, Yanko. I want to hear from others. Even Melody, I know Sisonia shouldn't speak at this point because she has spoken already numerous times. So I'm waiting for the others. We are wasting our time. I have the class. So don't waste time.
Plus beta.
Speaking, please.
Candy.
Candy, no Candy also.
Oh.
No Kelly. We're waiting for the others. Kelly, mute your mic, please. Thank you. Can the others please say something so as not to waste our time? I have a class, I need to go, and I need to get this over with before I leave.
Can you square root the other side?
That's what I want you to tell me. Do you want me to square root it?
Yes.
I insist this is not everything. It's close. This is not everything. So only you should not speak. I need someone else to tell me what is missing here.
The plus minus.
Plus minus. Plus minus because we are dealing with square roots. So basically, the point is there any reason why this plus minus is important? Anyone can speak now.
Because there's like a minus for alpha, beta, and the plus and minus can change that.
Not quite. Think again. Why do you think this plus minus makes sense? Anyone?
Because it's been square rooted.
I know. That's why we, in the real sense now, if you want to do this relation, if you want to use this.
Mr. Daniel, can I try?
Yes. Who's that?
I saw that you say we can choose alpha and beta. So if you choose a different one, you times it, use like the multiply by -1.
Wonderful, wonderful. That's it. Does everybody get Alex's explanation?
Can you say it again? I couldn't hear it.
Alex, say that again, please. Maybe I go back to this one. Alex, you can use question 1 to explain to them.
Okay. Where's question 1?
It's on the board.
Oh wait. So because you can choose the alpha and beta, you can be either of the two roots, and if you choose the different one, you need times the negative.
Use question 1. The roots are on the board.
Oh, the roots is.
This is the board. Can you see the board?
Oh, now I can see it. Sorry.
Thank you. So explain with that example.
So alpha is 3 and beta is -2. And if you switch it, you need to times -1 to get the same answer.
Does everybody get what he's saying?
Yeah.
Yeah.
In the other one, alpha is 3 and beta is -2, right? In this question. That's because I got x equals 3 and x equals -2 from previous step. I think Candy or maybe Krista, I don't know who, somebody got -2, then 3. So this person will have chosen alpha is -2 and beta is 3, right? So if I did alpha minus beta, what will I get in my case?
You'll get -20.
Really? Alpha minus beta?
5.
So it's
where does it come from?
-5.
Really? -5?
It's 5, and then for a second it's -5.
So I get, so for the sake of those that are probably slow in catching up, can you tell me how to get my alpha minus beta? Tell me how to get my alpha minus beta from here.
Three plus 2 is 5.
Well, I'm getting alpha minus beta. I don't know where your plus comes from.
Oh, 3 minus -2 equals
Just
3
said
plus
for the
2.
sake of those that are catching up slowly, how could you say plus? Isn't that more confusing? So this is where you got your 5 from. So the person that did this would have done what for alpha minus beta?
-2 minus 5 minus 3.
-5 again. Candy loves -5. And this would have been -5. So you see, someone will get +5, someone will get -5. So in the case of minor, it's not certain because it depends on what you have chosen as your alpha and beta if you solve the equation. That is why we have our plus or minus roots. Any questions? Questions?
I don't have any questions.
No questions.
Okay, so now this is where we will stop. I will put, I'd already typed a quiz. I will need you to choose if the expression is symmetric or not. It's just a 10-minute quiz. When we come next time, we will use these 5 relations. These are relations, they are like formula, okay? When I say relation, I'm referring to formula. So I'm referring to these ones, okay? I will use these 5 relations. The 3 especially is the difficult one. I think the first 2 are easy. They are just about sum and product of roots. We're using these 5 relations to work out what you did in the starter activity without solving the problem. So for example, if we need to work this out, how do we do it? If we want to work this out, how do we do it without going through unnecessary stress? Any questions so far? So when we come next time, we'll be making use of this. Please take note of these 5 relations, especially the last 3. I would suggest you write them over and over in your practice book and try to make sure you memorize. If anyone wishes to do some extension work on this ahead of next time, I will ask you to maybe attempt this question. Of course, you don't have to do it, but you can just make use of, if you have time, just see if you can evaluate this before next time, okay? So the question will be, if alpha and beta are the roots, so I'm going to write it on the board. Can you still see the board?
We can still see the board, but I don't think there's anything new there.
Yeah, I know. Can you just see the whiteboard?
Yeah, we can see the board.
Is it moving around or you have it on your full screen?
It's shrinking.
Bits of it's cropped.
Sorry, I'm trying to open 2 windows at the same time. Let's see how we can do that. But you can still see clearly, right? Even if it is shrinking or whatever you see happens to it. Okay, so I'm going to put the question here. So if you want to try it, you're welcome to try. So attempt. If alpha and beta are the roots of 2x squared minus 7x minus 3 equals to 0. I'll say work out, not just find the value. So Mr. Ironman knows he needs to work out. Work out. Alpha plus beta. Alpha beta. Alpha beta squared plus alpha squared beta. Alpha cube plus beta cube. over beta. One. Let's make use of 3 alpha squared beta cube minus 3 alpha cube beta squared. In fact, try alpha squared minus beta squared also. If you want to practice this, you're welcome to attempt those 7 problems on the same equation. Does everybody get that?
Yes.
All right.
Yeah.
Like I said, it's not homework, it's not compulsory, you don't have to submit. When we come next time, if anybody made any attempts, we will share it together. You don't have to submit anything to me. So if you just want to make attempts ahead of the next lesson we'll start with example, then I'll give you work to do, then we'll look at the next application. Okay? If there are no further questions, I will be ending the class now. Please say goodbye to everybody, and I will see you on Wednesday.
Bye.
Goodbye, everyone.
Bye, 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 bye.
See you guys on
Bye-bye.
Wednesday. Bye-bye.
Mr. Daniel,
Yeah.
can you go back to the attempt page? I want to copy down the question.
Do you want me to send you the picture on WeChat?
It's okay, I can take a picture.
All right, take a picture now.
Okay, thank you.
You're welcome. Eat a lot of fish as usual.
Yes, I will.
All right.
Bye.
Bye.